Boom! All right, folks, how are you going? So we're continuing our discussion of Surds, but we have to pause along the way. We're going to dedicate a whole video just to discussing the whole concept of what we refer to as the conjugate. The conjugate of a surd. Very important concept. Now, the conjugate in mathematics is not limited to surds alone. We also have complex conjugates when we're talking about complex numbers. But that's another topic for another day, for another video. And I have no doubt at all that there may be some other branch of mathematics, some other topic in mathematics, where the whole concept of the conjugate comes up. But something else. Conjugate something else. So, as I like to do all the time, we want to get into the vocabulary. We want to start the discussion about mathematical concept by discussing the vocabulary that we use. Alright? Now, the word conjugate, the origin of the word, right? Checking it out on my phone here. Let me clear some space on the board. The two main parts of the word. Right? I'm taking my time. It might take a little longer, but the idea is to bring life, add some life to the mathematics, right? You use now word. Let me try and think about what the word mean now. Conjugate. What's a conjugate? Right. The root of the word is Latin, right? So con, you have con, and you have jugum. Or jugum, not sure what the pronunciation is. Right? So con is together. Alright? Con is together. And jugum is to yoke. So in other words, the whole idea of the word conjugate, which comes from the root con and jugum, two roots, Latin roots. Right? Is to yoke together. As seen here, Latin conjugare. Conjugare. Right? Conjugare. So this is probably a more full expression of the word. So, and of course the word evolved from conjugare to conjugate and then conjugate. Right? The whole idea is that you're yoking something together. You yoke something together. You join things, two things. It could be two or more things, but we talk about two things joined together. So, two common examples of words that sound pretty much like conjugate. One is the word itself. No, it's not the word itself, but it's close. So, in prison, we have the concept of what we refer to as the conjugal visit, where the prisoner will be allowed a visit from their significant other. A man in prison, they allow the girlfriend to come. Woman in prison, they allow the boyfriend to come. Husband, wife, whatever it is, they have special places for them to go and conjugate, so to speak. Right? We're talking life here, real things, sex. We're not trying to hide nothing from nobody. Right? So we allow the person's partner to come so that they could be yoked together, they could be joined together. So that is what we refer to as a conjugal visit. Right? Very similar to the actual word conjugate. We know about conjoined twins, for example, where you have two twins and they join together at some part in their body. We refer to that as conjoined twins. Right? Conjoin. It sounds very much like conjugate. That's the whole idea. What's all this about? Alright? What is the mathematical significance? Well, let me look at the actual word itself now. So we just looked at the etymology of the word. Etymology. E-T-Y-M-O-L-O-G-Y. Go and look it up. Etymology refers to the whole thing of looking at the origin of words, where words come from, how the word evolve over time, etc., etc., etc. Right? Here we're talking maths, but maths is language too. Yeah. Right. So let me talk about the actual definition of the people word now. Again, we're using the phone, right? So the word conjugate has different meanings in different contexts. We have a grammar context, we have a biology context, we have a technical context, we have a biochemical context, we have a mathematical context, we have a biology context, etc., etc. Right, I'm not going to go into the details of all the different contexts. Suffice it to say that in every context in which the word conjugate appears, there is the concept of things joining. And it's usually two things. Two things joining, and they usually join to create something else. Alright? So how does that apply in mathematics? How does that apply with specific reference in this video to surds? Because remember, we're talking about surds, eh? We're talking about surds. If we just talking conjugate, we could talk all kind of other things. We could talk complex numbers too, but we're not here to talk about that. So let me stick to surds. How does the concept of conjugate apply where surds are concerned? Well, first of all, with the concept of joining, we impose some conditions on the joining. So in other words, we have two surds and we join them together in a particular way by multiplication. Alright? So it's not just any kind of joining. We could join by addition too. But we're not talking about addition. We're talking about multiplication. And the result we're looking for is a rational number. You see, that whole concept returns again. Alright? So in our previous video, we saw that we could rationalize a denominator in a fraction where you had a surd in the denominator. Now we're just looking at a surd, and in terms of conjugation, we usually refer to a compound surd. Alright, and I'm going to go a little further when we're talking about, in fact, no, I'll just leave that alone. Alright, I'll leave that alone because, well, no, I wouldn't leave it alone. Let me say I have a surd 2 plus root 3. Let me say I have a surd root 5 minus root 3. Both of these are examples of what we refer to as compound surds, which we already discussed in a previous video. Right? Compound surds. But both of them can also be described as binomial surds. Right? A binomial surd is simply a surd with two numbers. Right? Binomial, binomial. Alright? That's basically it. Because we could have a surd that looks like this. We could have a surd that we could have 2 plus root 3 minus root 7. That's a compound surd. We could have root 5 minus root 3 plus root 11. That's a compound surd too. But this is a trinomial. Tri. Right? Because they have three numbers. This here is a trinomial. This here is also a trinomial. Alright? So simple vocabulary, simple words and phrases that we introduce to get your thinking good. Right? So for the purposes of ADMATS, you will almost always be dealing with binomial surds. It's highly unlikely that you will have to deal with this in an ADMATS environment. Maybe in Form 6, not for ADMATS. So for ADMATS purposes, we generally dealing with these guys here. Binomial surds, compound surds. All right? And when we talk about the conjugate, we basically referring to these guys here. All right? So we just mentioned that with respect to these compound surds, these binomial surds, when we're talking about conjugate, we join in, but we join in by multiplication to get a rational number. So in other words, you're sensing this theme running through the whole thing. This fundamental idea where the end product is a rational something. There's some kind of rationalization going on. So in the previous video where we rationalized the denominator, you did something to the whole fraction so that in the denominator you move from a surd to a rational number. Over here now, you have a compound surd, a binomial surd, and again, the idea is the same. You apply a different set of variables, but the fundamental idea is the same, in that you're moving towards a rational outcome, so to speak, a rational number. So in other words, with the conjugate, you have two surds, which when you multiply them by each other, the answer is a rational number. So in other words, each of these and all other surds that look like that, binomial surds, where you have two numbers connected either by addition or by subtraction. Right? Let me make that clear. 2 root 3 is not a binomial surd, that's a mixed surd. Right? Root 5 by root 3, root 5 by root 3 is root 15, right? So root 5 multiplied by root 3 is not a binomial surd. In other words, it is not binomial just because of the existence of two numbers. Don't confuse that. You might say, well, it's two numbers, so it's binomial. No. What makes it binomial is that the operation is either addition or subtraction. So you have two numbers that are linked by addition or subtraction. The reasoning behind that is another story. We could deal with that another time. But that's what it is, binomial. A binomial, a compound surd. Right? A compound surd because they have either two surds coming together or a rational number and a surd coming together in the same expression. So these guys, each of these guys and all other surds that take this form, binomial, compound, would have an associated conjugate, which when you multiply it by the original surd, you will get a rational number. Alright? So what we talking about here? Let me go straight to the heart of the matter. How do we find the conjugate of these types of surds? Well, it's very simple, you know. It's very, very simple. In this particular scenario, the only thing you need to do to find the conjugate of a binomial surd, a compound surd, is to just change the sign between the two entities. Let me repeat that. To find the conjugate of a compound or a binomial surd, the only thing you need to do, the only thing you need to do is to change the sign between the two numbers, between the two entities. Let me demonstrate. So, based on that definition, we expect that the conjugate of 2 plus root 3 would be 2 minus root 3. Yeah, no problem. Right? Based on that definition, we expect the conjugate of root 5 minus root 3 to be root 5 plus root 3. And let me make life nice now. How about if we have surds with fractions? So let me make life easy by dealing with this guy here. Let me say I have 2 over 5 plus root 3 over plus root 3 over 4. Right? There is a whole surd there now. And based on that, you expect that the conjugate of this would be 2 over 5 minus root 3 over 4. How about if we have, let me switch up these guys here. How about if we have, let me use this one. Let me use this one. No, we have minus root 3. Let me take a negative surd, man. If you have minus root 5 minus root 3, let me say plus root 3. We change the sign, that's what's fine. You expect the conjugate of that to be minus root 5. So in other words, the minus in front of the root 5 doesn't change. See? The only thing it's changing is this. So you'll get minus root 5 minus root 3. Alright? So these are examples of conjugates. So what I'm going to do now is to multiply each one of them and demonstrate that you will in fact get a rational number. So I need to write these down in the corner because I will need to refer to them. So I'll say 2 plus or minus root 3. See? A nice, concise way of writing anything. Alright? So if I multiply these two, what do I get? 2 plus root 3 multiplied by 2 minus root 3. Alright? I'll get what? 2 by 2 is 4. Minus 3 root 2. Minus 2 root 3, sorry, my mistake. Minus 2 root 3 plus 2 root 3 plus 2 root 3. Root 3 by root 3 is minus 3. You'll get minus 2 root 3 plus 2 root 3 is you'll get 4 minus 3, which is equal to 1. Alright? So next to this guy here, I'm going to put 4 minus 3 is equal to 1. You'll see where I'm going with that shortly. So the final answer is 1. Rational. Whole number. Whole number. Rational. Right? So you see that. So let me deal with our good friend here now. You have root 5 minus root 3 multiplied by root 5 plus root 3. Alright? Root 5 minus root 3 by root 5 plus root 3. Well, there we go. Sorry about the little rubbing off and thing. Root 5 plus root 3. Right? Right, we're going again. Root 5 by root 5 is 5. Root 5 by root 5 is 5. Root 5 by root 3 is plus root 15. minus root 3 by root 5 is minus root 15. Root 3 by root 3 is minus root 3 by root 3 is minus 3. So you get 5 minus 3, which is equal to 2. So we're looking at, I'll leave it, let's see it for a little bit. Watch it, and then we go in now. So root 5 plus or minus root 3. Same form we're writing it in here, right? Root 5 plus or minus root 3. That is the 2 thirds, and you get what? 5 minus 3, which is equal to 2. Rational again. So we go in. How about this guy here? Let me do it. So you have 2 over 5 plus root 3 over 4. 2 over 5 plus root 3 over 4 multiplied by 2 over 5 minus root 3 over 4. Well, let me multiply now. 2 over 5 by 2 over 5 is what? 4 over 25. 2 over 5 by minus root 3 over 4 will be minus 2 root 3 over 5 by 4 is 20. Alright, excuse. 2 over 5 by minus 3 over 4 minus root 3 over 4. And you have the same thing here. Root 3 over 4 by 2 over 5 plus 2 root 3 over 20. Root 3 over 4 by minus root 3 over 4 is minus 3 over 16. Minus 3 over 16. So what you get? You get 4 over 25 minus 3 over 16. That's equal to what? 25 by 16 is how much? 25 by 16 is 400. 400. You'll get 4 by 16 is 64. And 3 by 25 is 75. Over 400. Right? Which will be minus 11 over 400. So, rational, in this case, it is not an integer because we didn't start off with integers. We started off with fractions. So it stands to reason that when you do your maths and you come down here, you will get a fraction. But this is also a rational number. Minus 11 over 400, that is rational. As in ratio. We discussed that in a previous video too. So, just as I did in the past cases, we chuck this up. Let me step aside so you can watch it. Watch it for 2 minutes there. Take out 2 minutes and watch it. Thing looking nice. We gotta get accustomed to working out these things. That is what ADMATS is. And just as we did before, we took 2 over 5. So we're going up in the corner here now, right? 2 over 5 plus or minus root 3 over 4. Root 3 over 4. And when we rationalize and we do what we had to do, sorry, when we multiply the two conjugates, remember it's two conjugates, eh? It's two conjugates. One is just the conjugate of the other. Alright? We get what? We got 4 over 16 minus, sorry, we got 4 over 25. 4 over 25 minus 3 over 16. And that was minus 11 over 400. Okay. How about this guy here now? So we have minus root 5 plus root 3 in brackets by minus root 5 minus root 3. And that's equal to what? There we go. Minus root 5 by minus root 5 is plus 5. Minus root 5 by minus root 3 is plus. Root 5 by root 3 is 15. Root 15. Plus root 15. Minus 3. Sorry, plus root 3 by minus root 5 is minus root 15. And root 3 by minus root 3 is minus 3. Let me check that again. Let me double check. Excuse me. Minus root 5 by minus root 5 is plus 5. Minus root 5 by minus root 3 is plus root 15. Alright. Plus root 3 by minus root 5 is minus root 15. Plus root 3 by minus root 3 is minus 3. Bim bam, that's gone. So you get 5 minus 3 is equal to 2. Alright. So let me put the answers down. Take a 2 minutes and watch it again. Watch it again, man. Watch it. You see how nice it's looking? Right, we're going again. So when we have minus, right, I had put the minus, that is all right. I wanted to demonstrate to the minus sign in front. So minus 5 plus or minus root 3. Right. Minus root 5 plus or minus root 3. We get 5 minus 3 is equal to 2. All right. So what we leading up to now? I want to show you something. And if you understand this, it will cut your work in half when you have to conjugate. When you have to conjugate? No, not conjugate. When you have to multiply a binomial surd, a compound surd, by its conjugate. Remember, we said just now that when you multiply a binomial surd by its conjugate, you're supposed to get an irrational number. Right? And we actually did it. And you saw the result in each case. In this case, the result was 1. In this case, the result was 2. In this case, the result was minus 11 over 400. In this case, the result was 2. All right, no problem. What I get in that? If you notice, in each of these 4 cases, and in every case like that, what we'll basically be utilizing is the difference of 2 squares. Right? And that is a technique that we learned early in maths, in the algebra. We learned it as part of the expansions and the factorization. Right? But the whole argument applies even when the powers are not a square power or even power. So for example, 2 plus or minus root 3. We saw that that was basically 2 plus root 3 into 2 minus root 3. Difference of 2 squares. So as soon as you see this, you know immediately that the answer is 2 squared minus root 3 squared, which is 4 minus 3, which is equal to 1. Remember we said that the property of the conjugate is that it's basically the same entities and you just change the sign. That's all. And when you do that, you find yourself right back where we were back in the algebra when we said that a minus b into a plus b is equal to a squared minus b squared. Yeah? You'd have done that some time ago in maths. This is one of the fundamental laws of basic expansions, and we use it when we factorize in 2. Look at right here. A plus b into a minus b. A squared minus b squared. Easy peasy. Simple dimple. Yeah? So using that now, we're going to just run it through for all of them. Alright? We're going to demonstrate. Same story. So root 5 plus or minus root 3 is what? Let me see. Root 5 plus root 3 in brackets root 5 minus root 3. Those are the two conjugates. So in other words, this is the conjugate of this, and by the same token, this is the conjugate of this. Is a plus b into a minus b. Root 5 squared minus root 3 squared. Root 5 squared is still 5. Root 3 squared is 3. 5 minus 3 is 2. Yeah? Then we do the same thing for our friend on top there. 2 over 5 plus root 3 over 4 multiplied by 2 over 5 minus root 3 over 4. Again, same difference of 2 squares. Watch it now. 2 over 5 squared minus root 3 over 4 squared, which is 4 over 25 minus 3 over 16. Alright, and then you work it out. You reach here with the difference of 2 squares, and then you work it out. And you get that. Alright, so we're going again. Minus root 5 plus or minus root 3. It's supposed to be plus or minus, eh? Right, plus or minus. So basically, what we're talking about here is same story. Minus root 5 plus root 3 in brackets multiply by minus root 5 minus root 3 will be equal to, watch it now, minus root 5 squared minus root 3 squared. Minus root 5 squared is 5. Root 3 squared is 3. 5 minus 3 is 2. Alright? So in other words, once we are aware of this, we could make direct and immediate use of it when it comes time to utilize the conjugate of a compound set. Because the nature of the definition of conjugate means that you will end up in a situation exactly like this. A minus b into a plus b. And once you have that, you know that when you multiply those two, you'll get a squared minus b squared. And that is why when you multiply a compound, a binomial surd by its conjugate, you will get a rational number. Because of this, the two terms in the middle will cancel out, and those two terms will be the terms with the surd, as you would have seen when we went through it on the board here. That is why sometimes I make sure and demonstrate the working, right? In a lot of cases, people will just say, well, so and so is so and so and so and so is so and so. Boom, done with that. Sometimes the student will understand it when they see it written out and explained. Sometimes, however, the student don't want to make the time to listen and to watch and to learn for more than 2 minutes or 3 minutes or 5 minutes or 10 minutes or however long. At that point is all on the student, because as I tell my students repeatedly, and as I am saying now, if you're serious about learning anything in life, anything, it doesn't matter what it is, at some point you will be called upon to focus for an extended period of time, and in a lot of cases you'll be called upon to do that repeatedly. There is no shortcut if you're trying to learn something and learn it properly. Alright? 2022, we live in a world now where everything seems to be focused on doing it fast, doing it quick, doing it now. Trying to find the shortest possible route to whatever it is you're looking for. That does not work. That is just not how life is constructed. You could consider it from a physical standpoint. You could consider it from a philosophical standpoint. You could consider it from a religious standpoint. You could consider it from a spiritual standpoint. Even from a humanistic standpoint. Doesn't matter. If you're trying to learn something and you're trying to learn it properly, that's the operative word. The whole idea of doing it fast is out of the picture. Alright? So let me get that out of our minds. If you're doing ad maths, sometimes you have to take the long route to get to where you're going. Right? So you see it for yourself. We demonstrated. So now you know that anytime you have to multiply a surd by its conjugate, binomial surd, you'll end up here, difference of two squares, and you could employ the difference of two squares immediately. You don't have to multiply the whole thing out. You just go straight to difference of two squares. And that is how you multiply a compound surd by its conjugate. Of course, we're talking about binomial surds. Right? Because as we saw before, you can have a compound surd with more than two terms. So we're only dealing with the specific case of surds with two terms, which will allow us to reach here. All right? So with that being said, let's make sure the mic is Jersey. So with that being said, we bring this video to a close. So now we're in a position to get to the last step in this discussion of surds, which is where we will actually now utilize this to conjugate surds, where we have binomial compound surds appearing in the denominator or in both the numerator and the denominator. Alright? So, check it out. Coming up in the next video.